Well, good day and welcome to Logic and Reason. Today's show is about the scientific method. We also have a channel announcement for everybody this morning, but before we get into that, let's go around the room and see who's here. I am one of your co-hosts, Logic of Logic and Reason, and with me is my co-host, Reason.
Well, hello, everybody. This is Jeff, or better known as Steaming Cup of Reason, and welcome to the show. We've got a great one lined up for you today. We're going to be talking about the scientific method. Logical?
And joining us today is two of the smartest gentlemen that I know besides myself. I'd like to introduce to you AB Science. AB?
Hey, good afternoon, everyone. My microphone is turned on. Good afternoon.
What's going on in your neck of the YouTube world there, AB?
I'm just currently getting bombarded with lots of comments on, the first installment of my series on Theory Apophysis and his magnetism nonsense.
Oh yeah, I've seen some of that. That's been really, really good. I can't wait to see part 2 of that. And
absolutely.
Let's see. Yeah, Jeff, go ahead.
And also joining us today, returning from last week's show, our good friend, BlueMarbleScience. Hello, Blue. How are you?
Good morning, everybody, or afternoon, or evening, wherever you may be listening to us from. How you guys doing?
We are doing great. How are you?
Wonderful, wonderful.
It's early in the morning for me, but I'll live. So what's going on in your neck of the YouTube world there, Blue?
I've primarily been trying to recover from the holiday season, probably the same as everybody else. hoping the mailman falls down and doesn't put all those bills in the mailbox.
Oh, God, and keeping the stream healthy and behind the scenes, covering all of our whistles, bells, and dials, we have our own Teddy Bogle. Teddy, say hi.
All right, troops, how's it going? Happy Sunday to you. I'm with you there, Blue, by the way, with recovering for the Hogmanay in the new year. But then again, in Scotland, we do it right. We take 2 days off, not just one.
It sounds like a good plan.
Yep. And our chief mod is with us, the incomparable Amy Hogan, to keep everything in the live chat and in the voice chat on an even keel and keep us honest and happy. Amy, say hi to everybody.
Good morning, everyone. How are you?
We're good. How are you?
Doing very well, thank you. And thank you very much, AB and Blue, for coming on today. Thank you.
Yep. And everybody in the live chat, just to reiterate, although most of you already know, if we do end up getting a conspiracy theorist in the live chat, they can go ahead and spout whatever nonsense they want. If their comments, questions, or concerns are on topic, we may even address them here in the live chat, in the voice chat, provided that nothing they're saying is completely socially out of line. You get the drill. Just don't time them out unless you absolutely have to keep us from getting community strikes and whatnot, right? So with that, channel announcement. Today will be the last broadcast on this channel. That doesn't mean this show is going away. It's just being moved. The Shills is being rebranded as the I Network, EIE, Entertainment, Information, and Education. And we have decided, as part of the Shills team, to move Logic and Reason to that platform. This channel will still exist as kind of a redirect for everybody, but our next show on January the 19th will be from the new iNetwork. So go ahead and mark that on your calendars so that when you come to visit the show, you're not in the wrong place.
Absolutely. We're looking forward to the move. It's going to be great. And we will be also replaying the episodes on this channel after the fact. So if you happen to miss the actual live broadcast, don't worry, you can still come here and catch the replay.
Yep. And so just in case anybody over on the Shills channel hasn't been exposed to Logic and Reason, what we're going to do is mirror our previous episodes in the next 2 weeks to bring everybody over there up to speed what this channel is doing before we do our first live broadcast over there. So this coming Monday through Friday, one each day, our first 5 episodes will play, and then the following week, Monday through Friday, our second 5, 5 through or 6. Yeah, you get what I'm saying. It's still early in the morning for me and I need more coffee. But with that, let's go ahead and open this conversation. The scientific method. What is it? How do conspiracy theorists mess it up, and how can we help educate them? And I'll turn this over to Blue Marble Science and AB to get us started. Gentlemen, which one of you would like to go first?
Oh, I want AB to go.
All right. Okay. The scientific method is simple. It is just a loosely defined framework in which we investigate stuff in a way that allows us to remove human bias and allows us to get the best available description of the world around us.
That's pretty good, concise description. Blue, what have you got?
Yeah, and that's exactly what it boils down to. It is not contrary to what many of the people on the flat Earth side of life seem to think. It's not some hard, fast, rigid set of steps that you have to go through in order to assure yourself that you've done what AB said, remove all the biases, and conducted an experiment or an observation that doesn't allow you to fool yourself into believing things that just simply aren't correct. So as long as you do something like that makes sense, you are following the scientific method.
Yeah, and the way that the conspiracy theorists describe the scientific method is a very grade school. I learned what they're talking about in the 3rd and 4th grade. Very clear cut. One step in line and everything. And but that's a very, very narrow definition, especially when they start talking about dependent and independent variables. Because there are observational sciences that doesn't have the independent variable, dependent variable like astronomy. But what they're doing is they're trying to invalidate those branches of science, which is absolutely ridiculous. And if any of them would care to do just a little bit of research, they would find that there are different types of the scientific method and often used in conjunction with each other.
Yeah, that's absolutely true. It's oftentimes not nearly as simple as it sounds when you actually are doing true scientific experiments. Many times you're going to run into conditions where you don't just have an independent variable; you got a whole bucket full of them. You got to figure out how to hold all but one of them steady, and try to figure out what that one remaining one is doing. And I'm sure AB could talk about that.
Well, yeah, that is the thing. I mean, you do an experiment, and there are lots of variables which can be a thing. And then, so you've got your independent variable, you've got your dependent variable, and your control variable. But actually, what you just have to think about, what are your control variables? You can approach them in 2 ways, right? You've got your classic lab-based experiment where what you do is you try and keep the control variables constant, so they don't affect the outcome. But sometimes you cannot do that. And when you can't do that, you have to treat that during the analysis as a control variable. And how you do that is to actually treat it as another independent variable. It's simple as that. If you look at, for example, psychological studies, you develop your model in, say, SPSS or Starter or R, you set up, you select your independent variable, you select your dependent variable, and then you select all the other factors as well. And actually, if you go through the mathematics of the functions that are running behind it, actually, yeah, they are just independent variables.
In the psychology research, there's something we talk about called confounding variables that we still have to try to think about and control for. Things like is the person's gender, age, blood pressure, and all those kind of things affecting the outcome of this particular study. And it's not always easy to narrow it down, which is why we have to repeat experiments over and over and over and do the peer review process, to try to isolate all of those.
Well, yeah, and that's why one of the reasons why I would argue that the statistical sciences, like psychology, are actually the hardest, the most difficult sciences out there. It's because you end up dealing with things like 95% confidence intervals, and in physics that will be considered laughable, but in psychology, you have to remember, and that's a key part in what I said with the scientific method. It's about developing the best available description. And if that is your best available description, then yeah, that's fine. But psychology is really, really hard. And yeah, you do have those confounding variables. And as you go through your analysis, what you do is you test each of those variables, which you think may be confounding something somewhere. You do lots of little mini experiments on the data to see what the interactions are. And then you try and control for them, or you try to quantify those interactions. So you then control it for them.
Yeah, in research psychology, we use something that's called Bayesian inference method, which is a type of scientific method, but it's more concerned about probability factors than it is about actual falsification, because the human animal can be very nebulous, and very, like you say, very difficult to define.
Absolutely, and there's more than just a Bayesian statistics, but there's lots of methods available, and they are growing by the day, right? More and more different more and more approaches are being developed. You have the whole field of statistics, which interests itself in these exact issues, like how do we control for these variables, how do we quantify those interactions, and that's a big part. And that is a science in itself, which is currently being developed.
Yeah, then before we get to nerding out too much and forget about it, let's take a look over at Amy and see if she's got anything from the live chat that we might need to address.
Yes, I've got some good comments here. Digital Demonic Davro says scientific method is just a guideline in his opinion. It's not a case of you must do this and that. And then Alan Evans, who says, who would think it? Nobel-winning scientists withdraws paper because repeatably was not working, plus a couple of other errors. Scientists policing themselves. Professor Phil Bell says to AB Science, they quote the scientific method as a deflection to try and diminish evidence. And he also says to Alan Evans to expand on his comment, he says experiments that cannot be repeated are serious. You can be charged with fraud if they think you fudged it.
Well, you won't get charged with fraud because within science there's a very important there's a very important principle, and it's basically there's a privilege you have in scientific publishing which protects you from anything like that, like libel or criminal criminal charges for fraud and all of those things, but you can get blacklisted. And if you're a medical doctor, you can have your license revoked. We enjoy these protections, and these are absolutely essential for us to do our job. But yeah, if Nature, for example, blacklists you, then you're screwed because you can't publish anymore, and that is the end of your career.
A good case in point would be Andrew Wakefield with the anti-vaxxers.
Well,
yeah.
he didn't actually suffer any consequences for his falsification of the data because of the ethics issues that he also committed, which came to light well before that, and he was already had his license removed for lots of other things. So when the falsification of data actually came out, there was nothing that could be done anymore because there was, he was already blacklisted. I mean, he had his license removed for bribing children to take blood samples at his son's birthday party. So, after that, don't really come back from that.
Yeah. I also noticed with a lot of the flat earthers, when they're doing their so-called experiments, they keep harping on the scientific method and how it works, and they inevitably get it wrong. But the thing is, they go through it to the point where they come to analyzing the data, and that's it. They take that as the end-all, be-all result, and they don't look at it and say, "Well, where can I change this experiment, and see if I can find any change in the result?" They don't do that extra work, and I think that's where the biggest flaw is.
Well, and that's true, Jeff. And like we were talking before the stream started, so the flat earthers, they tend to, when they describe the scientific method, are describing a very basic deductive method, right? But when they are verbally describing it, they're using an inductive argument, and an inductive argument presupposes that the conclusions are part of the evidence.
Yeah.
Possibly. To give you an example, right? I got a result just before I broke away from work for Christmas. I got a pretty exciting result in, and I've over the past 2 weeks, all I've been trying to do is prove it wrong. I've been going through the data and I've been trying to figure out every possible reason why I could be seeing that result other than what I expected to see. And that's a key part, right? You get a result, and the first thing you have to do is assume that you're wrong.
And it's also, I don't know if I'm wrong in saying this, but during the process of doing your experiment, other questions arise that sometimes require you to rethink your hypothesis and rebuild your experiment to modify or to more accurately get better results. Am I wrong in that, or?
Yeah, because 99% of experiments go wrong. They do not work first time. I mean, I know lots of people harp on about and kind of dug onto Bob Nadell for his 15 degree per hour shift experiment and keeping it all hush hush. But actually, that is what you do, because when you don't get the result that you expect, it is perfectly normal. And even when you do get the result you expect, the first thing you do is assume you're wrong. And if you don't get the result that you expect, you assume that your experimental setup is wrong. Because in the whole step of troubleshooting, that is the most likely explanation for getting your null result. And it's, and you go through that, and that's fine. But it becomes even more difficult when you do get the result you're expecting for, because it is easy to go, yay, I got the results. Fuck, let's write it up, let's publish it. But no, you need to take steps yourself to try to figure out if there is any reason why you are seeing the result that you're seeing other than your proposed mechanism.
Oh, so results are never wrong. How you obtain the results, however.
Yeah.
You can go the wrong way about it and get the right answer.
Well, Yeah, absolutely. You can go the right way about it, get the wrong answer. If you don't know, and that's the other important bit is you have to understand your experiment, right?
Yeah.
If you don't understand every part of your experiment, everything that happens in there, then you cannot explain the results. So
Exactly.
There's unknowns.
Yeah, and I'm glad you brought up Bob Nodell there, AB, because, I know a lot of people harped on that, but I personally didn't have a problem with him trying to keep it quiet at first and then controlling for another variable that he thought might actually be interfering with his initial results. So he set it up, did it again, but the difference between what Bob was doing and what we do is eventually, as we keep getting the same result over and over, we eventually at least say that I will accept this as provisionally true until other information comes to light. Bob wasn't doing that.
Yeah, absolutely. But at first, he was perfectly in the right to kind of go, let's keep it hush hush. The experiment must be wrong. But yeah, as time goes on and as you repeat the experiment and make modifications, and you still keep getting the same results, that becomes less justified with time.
Yeah, that's exactly right. I mean, if you get you get one result is nothing until you've done that over and over again and repeated it. You don't know what you have. But and I agree with everything AB said. I mean, the first thing that you always do is step back, scratch your head, and say, "Now, what the hell did I forget?
Yeah.
What am I missing here?"
Yeah.
There are times when you don't even have a hypothesis going in. You're not really sure what is going to happen.
Absolutely, but and that's the key step. But the conclusions you can draw from that are completely different. I mean, a lot of science is being done by just going, what happens if I press that button?
Exactly.
I mean,
well, CERN's doing that. CERN has been doing that since.
Well, I mean, CERN has got a very clear hypothesis-driven approach. They're not quite just pressing buttons, but we had Andre Geim, who he was the guy that did the floating frog, but he won an Ig Nobel Prize for that, which is awesome. Don't scoff at the Ig Nobel Prizes, they're the best. But he just went, oh, what happens if I do this with some pencil rubbings and sticky tape? What happens then? And he isolated graphene, and he won a Nobel Prize for that. Right? Those kind of things are absolutely essential. You just got to play around and press a button and just see what happens.
Yeah.
And one of the things I wanted to ask both Blue and AB is that, in my Occam's Razor video that I put out a while back, I briefly described, how that a mental model works, and was talking about it's really meant to kind of keep things simple, but I've never really worked in a physics lab the way AB does, or a computer lab the way Blue does, so I'm curious to know just how convoluted some of y'all's experiments can really get.
Oh wow.
Wow.
It can get very complicated, but it can look very complicated, but a lot of the time it is all very simple. So a while ago, I spent a week at Diamond Light Source, and I'm going back there again. I've just been awarded the funds to do another 2 weeks later this year. And it looks extremely complicated. I have no idea what 90% of the stuff does. The engineers know, and I trust in their expertise and everything. it's a massive facility. It is at the center there's a particle accelerator with a circumference of about 500 meters, and then lots of tubes and bells and whistles coming out of it. It all looks very complicated, but the experiments themselves, the actual business end of it is very simple. There's just a beam, there's an X-ray beam coming in, hitting some stuff and scattering off it, and we detect that. That's all very simple. It looks very convoluted. It looks extremely complicated, and it is, but the experiment isn't.
I'd like to expand a little bit on a point you made. A lot of the stuff seemed complicated to you, but you trust in the expertise of the engineers who know. I think that's a big problem with conspiracy theorists when they're doing their experiments. They have no trust in the other disciplines that play a big part in their research.
Well, yeah, and if you don't have trust, and this trust is not blind, right? Because they see it as trust, as blind trust. It's like, no, once upon a time, I mean, if you're in a, for example, logical, I'm sure you've done I'm sure you've done a linear regression at some point.
Yes.
Yeah. So, do you know how it works?
On a very basic level, I mean, I studied research psychology in my initial education and training, but I did not move forward to actually become a research psychologist. I'm a clinical worker, so I just got the undergrad part of it, but didn't really move forward with that to actually get overly comfortable with it.
Yeah, but during your undergrad, it was explained to you once.
Yes.
And it made sense to you. You may have forgotten it.
Yeah.
But
I mean, moving from point A to point B equals, point C eventually, but
you know that once upon a time you understood it.
Right.
You've forgotten it and everything, but you remember that was a thing. And you trust that it works because you understood once upon a time how it works. And that's the same thing, right? With trusting other people's expertise. This expertise is not blind. It's because you're either in a position where, I knew how this worked once and that's why I trust it. Or it is, well, I never understood how it worked, but I know that I could find out about it and I could falsify it.
Yeah. So, today when I read a peer-reviewed paper and they cite a linear progression, you're right. Since I hadn't gotten that in my education at one point, I may not completely understand what they're talking about because, like you say, you forget things over the years. Because that was 15 years or more ago that I had that class, and but I can understand, that the guy knows what he's talking about because this is in line with what I'm remembering. Right? It's kind of like my algebra. I haven't had algebra in 20 years. I couldn't do a quadratic equation to save my life today, but when you do it, I can trust that you're doing it right because you do it every day.
Well, yeah, but that's the point, right? And it goes even further. It's like there is one particular thing I'm currently investigating, and the maths behind it is mind-bogglingly complicated. It will take me quite a while to fully understand what is going on, and I don't understand the whole derivation, but I know the result. And I know that the information is out there and it exists. It is publicly accessible, and you can. It is publicly accessible, and you can test the whole logical flow that comes to that conclusion, that result, on a logical level. But all of that is not important to me. The result is important to me because the result is something I can test.
Yep, and this is exactly why when we're doing our experiments or doing our current studies, we don't have to go all the way back to stick and twig technology and discovering fire all over again before we move forward. We can, as they say, stand on the shoulders of giants and see further.
Precisely. That's the whole point.
Exactly right. And Amy, have you got anything from the side chat that we should know about?
Yes, I do, actually. I have some really good comments here. Professor Bell clarifies, and he said he meant professionally sanctioned, not criminal, but your career is finished when they were talking earlier. The casual spaceman says falsification of data as a medical researcher is a huge no-no, let alone accusations of misappropriation of funds meant for research. Professor Phil Bell says you have... Yes, exactly. You have to understand sources of errors. And then Ugly German Truths asks a good question. Shouldn't any serious test series try and go for a couple dozen measured results anyway to exclude any freak outliers? The casual spaceman was talking about Andrew Wakefield, and he said so he wasn't getting the results he wanted, so he falsified the results to fit his narrative that inoculations cause autism. And John Rapp has a funny comment. That's what most flurfs do, essentially, is push people's buttons. Mm-hmm. And then Terry Davies says, mix chemical A with chemical B. What's the worst that could happen? And definitely...
Ask Riley.
Yeah, exactly.
Big shout out, man.
The answer is Chernobyl. That's what can.
Big shout out to
And I
Ryan.
haven't peeked over. I'm sorry, what did you say, Daddy?
Just saying big shout out to Terry and the Aussie perspective, man. Brilliant. When I tuned in
yeah.
before I came in here, man, it was a good wee show, that, man.
Always enjoy Terry Davis's streams. If anybody in the live chat hasn't met the Aussie perspective over on Terry Davis's channel, I encourage you to do so. It's a lot of fun. But I hadn't looked in the live chat recently, but I noticed earlier that Janie in the live chat was talking about something about doing an experiment of her own today during this stream. Something about how many jugs of moonshine is going to take before she falls over.
What are your controls, Jenny?
I have run that experiment many times myself.
I think that is one of the most oft-repeated experiments in the world.
Yes.
And you keep getting different results, don't you?
Yes, it is.
Well, see, that goes back to the confounding variables, body mass, age, metabolism, blood pressure, all of that plays a part in those results, yeah?
Absolutely.
Well, just always keep one thing in mind. It is completely possible, and I have known guys that thought they could draw an entire family of curves through one data point, but it doesn't always work really, really well. The more test results you have, the tighter those confidence limits become, and the more the better you feel about what you're saying.
Yep.
Yeah. In a moment ago, I think it was Jeff had mentioned something about Anthony Riley, and it put me in mind of his egg experiment. Right. What I thought was fun was about it was when he used the parts per million meter, and he measured it and he stated the number and then says, I don't know what that means and it doesn't really matter. Well, I'm sorry, but in any scientific experiment, you have to know what the tools you're using are and what those results mean before you can come to any conclusion. So if you're going to use the ppm of the salt in the water, you're going to have to know what that means.
Yeah, absolutely.
Absolutely, because if there's something in your, if there's a key part of your experiment, you don't know what it means. The key part here being your independent variable, then you can't draw any conclusions, right? And that's the other thing, right? Measuring something is not, it is not just to show that, you did indeed change it. It allows you to do an exact analysis, because if you do an exact analysis, then you get confidence, and also it becomes falsifiable.
Mm-hmm. Absolutely.
And that is the important bit, right? He didn't record anything, right? Well, he will say he recorded it because he recorded it with a video camera, but with recording, I mean, actually write shit down, measure stuff, and quantify, and not just to readings of a ppm meter, and actually measure the force that's on the egg. You've got to measure lots of different things. In that case, it's a very, very simple experiment that you managed to fuck up. But then it becomes falsifiable, and that's a key point.
Yeah, no scientist of any discipline worth their salt is going to throw out a result or a reading or a piece of evidence just to get their conclusion. And if they are, they don't get to publish anymore. So I can't see how a conspiracy theorist can start screaming at us that we don't understand the scientific method when they are on video repeatedly throwing out pieces of evidence that falsify their own claims.
Yeah. Absolutely.
Yeah.
So, Blue?
Well, I think Anthony, I don't want to pick on Riley too much. His attempt was pretty childish in my opinion, but you can use that as a learning tool if you want to, as a method. That's how you don't do science. You can do a lot of things, but don't do any of those things. He was wrong from the very beginning. There's no way in the world you could repeat an experiment. Needs to be repeatable, and you can only repeat it if you know what the hell you did the first time. And there's no chance that you can do that if you don't have everything recorded. You need to know the temperature. You need to know the pressure. You need to know the salinity of the solution before you started. You need to know how much salt you added. You need you need all of these things. Without that, it's just an observation.
And that's what Ugly German Truth basically just said in the chat, right? It is only science if you take notes.
Yeah.
And what actually gave me the idea for this particular topic was way back in early December, Anthony O'Reilly did challenge Blue Marble Science to a science experiment, but then he so narrowly defined it as to make the experiment impossible. And that's one thing I think we should mention too, that although we try to keep things simple, we try to streamline our experiments, there is a point when you oversimplify it to the point of absurdity that makes it completely useless.
Yeah, absolutely.
Yeah.
So for the benefit of the audience, what was the challenge?
God, I should have looked that up this morning before I got online. Blue, do you remember what that was?
I don't know. He's said so many things. I don't recall specifically what he was trying to tell me I needed to do or wanted me to do.
Yeah, I'd have to go on his channel and look that up again. Teddy, if you're not overly busy, I think that was in his community tab. If you can kind of look that up, I think that was somewhere around December the 7th through the 10th that he did that. Somewhere in that ballpark.
If I'm going to Leaky Warrior, I'm going to have to put my waders on first, right? Give me 2 minutes.
Okay. But yeah, we can keep yakking while you do that if you don't mind. I appreciate the effort, man.
Wash your hands before you come back, Teddy.
Yeah, absolutely. Absolutely.
I think I recall the post. No. Oh, God.
No. Give me 2 fucking minutes. Piss off, you fucking.
Uh-oh.
What the hell was that?
That was this cringy intro, wasn't it?
Yeah.
It's autoplay video when you go to his page, right? Community tab, right? Okay. Keep yakking, folks. Keep yakking.
Absolutely.
So I think that's that. Then I vaguely recall now what the post is, and it does lead to an interesting point. The flat Earth requirement that. The independent variable has to be the thing you're investigating. For example, if you want to investigate gravity, you have to manipulate gravity.
Yeah.
Which is just silly.
Yeah, That kind of is like the mouse experiment we were talking about before the stream there, AB. There's a basic psychological experiment with the mouse trying to find the cheese at the end of the maze, right? And it's designed to test memory and learning. And if I manipulate the maze, okay, you can loosely call that my independent variable. But that doesn't mean I'm making that mouse learn. He's learning on his own. All I'm doing is giving him different choices.
Absolutely. But I think it goes into it also goes into a longer process of science, and it is right with standing on the shoulders of giants, right? Because they seem to start as like, oh, you make an observation of a phenomenon, and that's your starting point, and then you manipulate some, the variable that you think is causing that phenomenon. But it's a little bit more complicated than that, because in an experiment, that is a nice starting point. But in an experiment, you get some results where you say, well, where you see that, okay, A is true. So if A is true, then B should happen. And so I tested that, and yeah, that works, and that's great. But then you take that relationship between A and B, and then actually you go, right, okay, so if this relationship is true, then we should observe this as well. And then you go and test that. And you may not be testing your independent variable all the time, your presumed cause, at least, because I'm wording this really badly. For example, if you're trying to investigate the relationship between the electric and the magnetic field. You take a time varying electric field, and you measure the magnetic field that is produced by that circuit, and you can then hypothesize about what the relationship is between them and everything, and what the mechanisms are, and you can then draw conclusions from that. So you have a proposed mechanism that relates the two, and that should give you then testable predictions that you can then go out and test as well. And that mechanism then becomes that presumed cause, and you can't manipulate that mechanism.
Yeah, that's like the conspiracy theorists will say that time cannot be an independent variable because you can't manipulate time. Well, okay, sure, I can't roll time forward and backward, but I can determine the time interval that my experiment's going to run. And that is an independent variable, because, the amount of time that something is running can affect the results.
Mm-hmm.
Absolutely. So, if we look at so if we look at gravity, right, we've got is this the right way to go about it? So yeah, if we look at Newton's derivation to come up with the universal law of gravity, he did this from observations of the Jovian moons, and he comes up with an equation, and then great. And then he tests, and then he goes, well, if that is correct with these parameters, then, okay, fast forward 100 years, right? And then if I drop stuff, it should accelerate at 9.81 meters per second. You're not manipulating gravity or anything. You're saying, if that is correct, then I should measure this. And you then perform a test to say, all right, my independent variable is height, and my dependent variable is time. And then I can drop stuff from different heights and measure how long it takes to fall. You're not manipulating gravity, but you are definitely testing a prediction that is made by this set of equations.
Mm-hmm.
Yeah, and the whole statement of, I manipulated the density, therefore density is a force, is a completely nonsensical statement.
Well, yeah, because that's because you're not you're testing this relationship, right? Okay, increasing the density changes the force acting on the object. Yeah, that's absolutely fine. I have no issues with it. But to then state that density is a force is completely wrong, because you can then test that you don't have to test whether that is a force, and you have to investigate that relationship. And then what predictions does that make? And if density is a force, then I've already developed a model and everything for it. So if that is correct, then we should observe things like heavier objects should fall slower than lighter objects, for example, just by virtue of how it all works. And then we test that, and then we go, oh, well, no, that's wrong then, because, they fall at the same rate.
Yep.
Yeah, it's correlational research, examining the relationship between variables, but that doesn't give you a cause and effect conclusion.
Well, absolutely. Because they say only in an experiment can you, and this is that irritating phrase, you can prove the cause and effect. Oh,
yeah.
Oh, that was Riley. Good.
I just, because that chomps my gears every time I hear somebody use the word prove, and it's like, no, we're not proving, we're providing evidence that suggests that this thing may be true or false. If you want a proof, take a mathematics class. If you want the truth, take a philosophy class, because those terms to me are totally misapplied when talking about science and the scientific method.
Absolutely, because science is about developing the best available picture. You cannot prove anything in science, and cause and effect are nice to have, but they're not. The key word being the best available picture. They're talking about, proving causation, and that's just correlative. That's not science. No, if the best available picture comprises just a series of correlations, that's fine. It is still the best available picture.
Yeah.
And it's not perfect. And to assume that our understanding of nature can be perfect is wrong. You cannot possibly think that we can have a perfect understanding of nature, because we can't prove anything. It's simple as that.
And nature does have a way of throwing us curveballs,
Absolutely. I mean, when you talk about when you talk about psychological research, I'm sure there's a lot of variables that you just cannot control. You cannot manipulate.
No, you can't. I was thinking about the Stanford prison experiment last night, and what that suggested about human psychology and overcrowded areas and that kind of stuff, and how aberrant behavior can happen even in so-called well-adjusted individuals, in close quarters. I was trying to think about that in terms of the way a conspiracy theorist tries to narrowly define the scientific method, and it gave me a headache, trying to define it in their terms. I just couldn't,
Well, firstly, the Stanford prison experiment was really bad.
Well, yeah, true, and kind of slightly unethical, but it still taught us a lot, even though it was not that good of an experiment.
No, it was unethical as hell, and it was performed really badly. It was so loaded.
Yeah.
Yeah, if you, I can't remember the exact details, but if you look into it, it's just, yeah, you just kind of go, huh? And you call yourself a scientist? That is not right.
Yeah, I know, but it is, like I said, one of those examples of even a bad experiment can teach you something, even if it's how not to do an experiment.
Oh, yeah. Yeah, absolutely. You know, because you still have your observations and stuff like that, and you can control for certain things. And it did show some interesting things, but the validity of it is questionable anyway.
Yeah. But the conspiracy theorists will still look at those types of experiments and say, well, because that was unethical, or then we have to throw out that entire branch of science. It's like, no, just that one experiment.
Absolutely. Yeah, that's. Well, that's the thing. It's rejecting something on the basis of the experiment. Well, of something not completely conforming to, well, especially in the case of conspiracies, some really arbitrary definitions. Rejecting something on the basis that the reasoning behind it is fallacious. Just outright rejecting it is not justifiable. You have to back up why you're rejecting it, and just hand waving comment of the ethics were bad, that is not good enough, because ethics are there to protect people. Just because something is ethically wrong doesn't mean it's bad science. It just means that the experimenter was a dick.
Yeah, but anyway, we haven't heard Amy's voice for a while, so before we get too far into this line of thought, let's take a look at the live chat and see what's going on in there.
Sure. Mike Bertelson said one of the most annoying conspiracy theorist claims is that data acquisition and analysis is not part of the scientific method, when in reality it's the most important part of the process. And he said, if you can't explain how your experiment is run and what it means, then you can't draw conclusions, and it isn't repeatable by someone else, which is key. He also said all of Riley's demos are claims, no evidence of the claim. When will these science deniers get that a claim is not evidence of itself? And then the casual spaceman had a question for the panel. Although I think I know the answer, he says. So am I right in saying that there is going to be plenty of occasions where I couldn't follow the scientific method while performing an experiment?
Nope.
Okay.
That was pretty straightforward, eh?
Yep.
It's pretty simple. If you're not following the scientific method, or the principles behind the scientific method, then it's not a good experiment. It's simple as that.
As simple as that. So, anything else, Amy?
I think that's pretty much it. It's except for Professor Bell says, yes, if you overboil an egg, you will cause H2S from the egg white to react with Fe from the yolk to create a film of Fs, which is a gray area. He's talking about boiling an egg. Nice. So that's good. But that's it. Thank you.
Excellent. Well, that does bring up another point that I was kind of reading about. And that is how the scientific method can change depending on the discipline of science in which it's being applied. Can you kind of expand on that a bit? Maybe, Blue?
Me? Okay. Well, Blue, did you want to pick that one up?
Before we do that, I think I found the thing that Logical was talking about from Anthony. We'll just run back to that real
good.
quick.
Nice.
This is what Anthony said. He said, I'd like to see you show gas pressure, but without a container. Do it in a vacuum. Get a. In other words, I want to see. Do it in a vacuum. Get a bell jar vacuum, evacuate, and then demonstrate gas pressure, but no balloon and definitely no pipe. If you can't do it, tell us publicly you cannot do it, and then explain how we have a gradient in a vacuum.
So, is that one as part of the video?
So, which is, I think you can see the reason why I ignored the request.
Yeah.
Yeah, that's a stupid.
Yeah, he's asking me to show him light in a dark room.
Yeah, pretty much, Yeah, when they make requests like that, it doesn't seem to ever occur to them that what you're really asking is to provide evidence of a pressure gradient due to gravity while in a gravity well of an enlarged mass like the planet you're freaking standing on,
Well,
Yeah, kind of where Pratt went wrong.
Yeah, this isn't Hitchhiker's Guide to the Galaxy. We're not going to go out there in space and build a planet to show you how an atmospheric pressure gradient or water sticking to the outside of a ball can actually work.
Yeah, it's
We
just
can still
unreasonable.
test and make inferences and test and show evidence for while standing on a planet. We don't have to go build a whole new planet.
Is that the one you mean?
Yeah,
Yep.
yeah,
I think that.
without the container.
Yeah. So, just make up something totally impossible to do, and then say, "Oh, see, I told you."
Yeah, exactly right.
But
Unbelievable.
I spent my entire career working in air pollution control, and some of the research work I did had to do with a particular type of air quality control system that collects solid particulate matter. Well, where do you get that from? It comes from various industrial and utility type processes. And we were particularly interested most of the time in the public utility, or large power generating coal-fired power plants. I'll just say it that way. And we did some pretty serious research on trying to understand the physics of that particular device. And now the scientific process has to be carefully considered and modified as required, because you're dealing with so many things that you cannot control anymore. I have no way of controlling the exact chemistry of the coal going into the boiler. Even if I could, the coal that's being burned right now was put in there yesterday, or the day before yesterday. It goes in a big bunker. So we don't know exactly what's going to be going on with that stuff. We can't hold boiler conditions exactly constant. These things are huge. I mean, you're talking 600 megawatt size power plants, and we're pulling a slipstream to run through a test device. It's not simple or clean or straightforward like experimentation could be in a laboratory environment.
Yeah.
So you have to be pretty flexible and understand what you can, what can be controlled and what can't, but at least record everything to the extent that someplace down the road somebody can sit down and do some analysis on the data and try to figure out what was happening.
Well, exactly, because you can't control them, you can't keep them constant, but you can measure them.
Yeah, exactly.
And and you can control for it in the analysis, right? So, for example, if you have an experiment with where your dependent variable is, the math says it's dependent on whatever your independent variable is and whatever the temperature is. Now, it's very difficult to control temperature, and if the relationship is y is equal to x times temperature, then as long as you measure the temperature, then you can just divide your measured dependent variable by temperature to get x, right? It's simple as that. Okay, it does get a little bit more complicated when you actually do real world stuff, but you can control for things in the analysis stage.
Yeah, we were investigating the particular physics involved, if you vary the spacing inside one of these devices between the collecting and discharge electrode systems. And, if you had an absolutely consistent gas stream coming into it, then it'd be a real simple experiment to do. But that's the problem. Mm-hmm. You're having to get your the material that you're running through this thing from that process, which is bouncing all over the place. And there's not a thing in the world we can do about it. But in the real world, that's what you're going to deal with anyway.
Well, precisely. I mean, as a general rule, if your experiment is simple, you're either investigating something that's not worth investigating, or you're doing it wrong.
Yeah, exactly.
Yeah.
Exactly.
Yeah, and you should never have the expectation that science is going to be exact. Although the engineering of our tools need to be exact, otherwise they're not going to work properly. Science itself is rather messy, It's kind of the way it is. But just because it isn't exact doesn't mean it can't teach us things,
Mm-hmm. Yeah. The scientific method and the scientific experimentation is not limited to the lab where everything is tightly controlled. That's just not the way science works. Sometimes you just can't do it in a lab.
Well, yeah, because, you have your lab-based controlled experiments and, they are great. That they are the types of experiment where you can have most confidence in your result, provided that they are performed correctly and you understand the system and all of those things. But yeah, then you've got field experiments where you still have your control over your independent variable, your dependent variable, but then you have your other control variables which get messy. You may not have as much control over it, and then you can also just go into the observational methods or the quasi-experimental designs that astronomy uses. Mm-hmm. And there are so many ways of investigating, and each approach has its own validity. And in medicine, there is a hierarchy of I can't remember exactly what it's called, hierarchy of authority or hierarchy of power, or something along those lines, which lists in order how good the evidence is for each type of investigation, where right at the top you've got you have your double-blind randomized clinical trial, and then right at the bottom you've got your case control studies, right? And there's lots of different approaches in between, and it's a tool that allows medics to identify how good a bit of evidence is.
Mm-hmm.
Yeah, and I'm glad that you brought up the observational studies, AB, because that's one thing that the conspiracy theorists try to just throw out the window completely as not being real science. Like in the case of astronomy, what was it, about a year and a half or so ago, when they released their findings about the black hole at the center of the galaxy and the stars orbiting it. That was a very long study that they were doing, and it was purely observational, until they got the results, and then they crunched the numbers to find out how fast these things were moving, but it still was science. It wasn't just watching paint dry.
Yeah.
Well, yeah, it's a very long investigation. As Mike Burton says, you don't do science in a 15-minute video, and yeah, just discounting observational methods because it's not science, because for their reasoning is that you don't control the independent variable. Well, that is just completely silly, because control over the independent variable will help establishing a causal link, and that becomes a little bit more difficult with observational methods. Now, they say correlation does not imply causation. Well, sometimes it does, but if you understand the system well enough that you're studying, then you can start doing that. And astronomy, we're talking about observational techniques. Astronomy tends to use something called a quasi-experimental design, and that's where you measure a system and you classify it and you describe it in excruciating amounts of detail. So if you look at, for example, galaxy formation, well, you can tell from known laws in physics how old a galaxy is, roughly. So if you want to test evolution, then you've got this very well-defined independent variable, which is time, and then you can measure whatever properties, and you can plot that against time, because in observational methods, one of the key issues is how well defined your independent variable is, and that is the limiting factor on whether you can determine causation, right? It's not where did you manipulate your independent variable? No, it's how well can you define it. If you can manipulate it, then you can define it extremely well. With observational methods, that becomes more difficult. But with quasi-experimental designs, they're essentially observational methods, but the data is so well defined that you can treat it as if an experiment, and it nearly carries the same amount of weight as a proper lab-based experiment, right? And this is the one of the economists and public health professionals. It's a key part of their toolkit and allowed us to figure out things out like smoking bans. Do they work? Do they not? Turns out they do work, right? And we can figure out a lot of stuff about this.
Yeah, and what was I just thinking? Oh, I think a part of the problem with the conspiracy theorist is, like with the observational things like astronomy, they'll watch a little half-hour documentary about, say, galaxy formation, but what they don't understand is the paper on the peer-reviewed paper on the galaxy formation is so excruciatingly detailed. It's very difficult to read, and it'll make your brain hurt. But what that documentary is doing is just in plain language, layman's terms, describing what was found. They're just not making the shit up, and they're not pulling it out of their rears. You can go back and read each of those papers, but you're going to have a higher educational level than high school in order to really read and absorb the entire thing.
Well, yeah, I mean, and that's the thing, right? Everyone is welcome to attempt to disprove current scientific theory. Everyone is welcome to try and falsify an observation or a conclusion, but it does come with a reading level.
Yeah,
absolutely.
Definitely.
yeah. That's one of my most irritating phrases from flat earthers. It's just a theory. Like they don't.
Yeah.
That drives me nuts.
That the version of the scientific method that they like to espouse, like we said at the beginning of the stream, is taught to 3rd, 4th, and 5th graders here in the United States, and I'm pretty sure similar throughout the rest of the world. But it's really just being taught on that level, on a level a child can understand, just to get them thinking in terms of logic, and scientific thought. But as you progress further in the educational process, that gets expanded a lot, and if you're just stuck on the 3rd grade level, you're not going to get very far, especially with trying to disprove, things like the globe and pressure gradients and things like that.
Well,
Yeah,
that's the thing. It's I think chemistry is it's a subject I do not get along with, but chemistry is a fine example of this, right? At school, you learn things like really, really basic stuff. You learn that you add one chemical to another, things happen. way exciting. Then a little bit later in school, you start learning about the structure of the atom. You know, you have a little nucleus, and then you have some electrons buzzing around it in tight little orbits, and lovely. Now, if you step out of the education system and treat that as correct, then you're wrong, right? Because then suddenly you go one level higher, and then you go, oh crap, that is completely wrong. It doesn't work that way. And you get that all the time in chemistry. Every level higher you go, you get more and more detail. And you and it's the same with the scientific method, right? You start early on in life, something very concrete. There are 5 simple steps. That's the scientific method. Yeah, but that's the scientific method that is useful for performing a little experiment that, you know, a 10-year-old would do.
Yeah.
You know, and it's that's fine. It's useful for that, but it
works perfect. Yeah, it works perfectly if you're baking a cake.
Yeah, I mean, when I'm teaching my kids in the class the scientific method, we teach just the basic method, and we're not teaching them that this is the end-all, be-all way to do science. What we're doing is we're trying to instill in them a pattern of thinking and a process by which they can find a specific result. We're just teaching them the process, the basics of that process, and how to think through that process, not make them scientists overnight.
Well,
yeah, absolutely.
I mean, you reach a level very quickly where the scientific method is not taught anymore, right, at universities or stuff like that, because it is just assumed that you know this and you understand the principles behind it.
Yeah, exactly.
And you can run with it. But I think we're kind of leading to the question you asked earlier about, is there one version of the scientific method, or does it change by discipline?
Exactly. I think it changes quite drastically from one discipline to another. Scientific method in the medical community is very different from the method used in your discipline, AB. Am I correct?
This is actually a point that I would personally argue against.
Okay.
Because actually, there's simple 5 steps. There's simple 5 steps that the flat earthers use. There are a few nuances, a few issues that I take issue with. For example, observation of a physical phenomenon. No, that's not required. You can just have the logical conclusion based on some theories and stuff like that, and predictions. You can investigate that. But the basic unit of the scientific method is quite simple, and you can follow those 5 steps if you understand them. If you know that they're not strict guidelines, because there's two approaches you can do. You can say, this is the scientific method for this discipline. This is how we use the scientific method in this discipline, and you can be very strict about it per discipline. Or you can just take one scientific method and you can just be really vague about it, so it applies to everything. And I find that a bit more useful, because as long as you remember that you have to take steps to remove bias and control your system that you are studying, and be analytical about it, and be open, be honest. You know, transparency is a big thing, and make sure that people can falsify it. Then if you just start with the really underlying principle of just systematically investigating something in a way that minimizes doubt and minimizes your own biases, then you are fine. And then suddenly you've got something that applies to everyone.
Yeah, exactly. In the simplest form, you take every step you have to take to ensure that you're not fooling yourself one way or the other.
Yeah, I don't think conspiracy theorists really listen to themselves when they speak, because they'll harp against observational techniques in science, while at the same time standing on a beach saying, "Looks flat, I'm done."
Yeah, true.
Yeah.
Oftentimes, and I found that true throughout my career. The experiment itself was relatively simple to do. It took a lot more time to design the experiment and set everything up than it did to actually do the work. I think that's probably true in a lot of fields. But if anybody wants to go back to prior to the time when we had these spiffy Google things that you could look up scientific method on. And see how things were done in we'll call it the good old days. Just read the actual Cavendish experiment sometime, and look at the thinking and controls that guy put into the work he did. And it's a beautiful example of how you properly account for all of the influences that might be there, that whether they're actually going to do anything or not, he accounted for them.
Well, yeah, because there was a lot in his experiment where he's kind of accounting for it and making sure that can't have an effect and stuff like that. And you're now kind of thinking, it's like, nah, you shouldn't have bothered. That was fine. That was not going to be an issue.
Or any peer-reviewed paper for that matter. Those things aren't locked in a safe somewhere in the ivory towers. They're open to the public, and in every single one of those papers there's a section in the abstract called method that describes in excruciating detail what they were doing and how they did it. And before I get really bruised ribs, I think we needed to look over at Amy and find out what's going on in the live chat.
Yes, please. We have some great comments here today. My mom bakes cakes, says flurfs are all full of gas pressure. Ugly German Truth says also what the FE mysteriously seem to have forgotten is that they started their claim with air pressure needs a closed container. You cannot have any different pressure with an open one, which BlueMarbleScience and others have proved, and water does also. Then the moving of the goalpost started. John Rapp says there's some atmospheric pressure in my vacuum even when I turn it on. And then Terry Davies and both Casual Spaceman have a question. They want to know if the both of you will come on an after show with them on Terry's channel. And then Mike Bertelson says, I was on a team investigating the effect of a crack in the wall of a pipe fitting that took 6 months, including physical testing and finite element analysis. It doesn't happen in a 15-minute video. And Professor Phil Bell says, observational experiments are often compared to other experiments to form conclusions about causation. And Mike Bertelson says, even at the elementary school level, it still includes basic data and graphing, something science deniers say isn't part of the method. The basic framework is the same for all investigations. However, there's usually different methodologies and techniques that will be unique to a given discipline. And Professor Phil Bell expands on that. The basic framework is the same.
Yeah. And I assume when Terry and Casual are talking about the two of you joining them for an after party, they're talking about Blue and AB, and that's okay. We Jeff and I don't mind being left out, really, because those gentlemen are a hell of a lot fucking smarter than we are. So, But thanks, Terry. I love you, man.
I'm sure Terry will very quickly modify his.
Oh, not that I have any Jewish grandmother that taught me how to do guilt trips or anything.
No, of course not.
Oh God. So,
Oh man.
Anyway, where were we?
I don't know. I kind of lost track here.
Yeah, I don't know.
AB was just going over the differences of the scientific method across disciplines. That's where we left off.
Yeah, and conclusion was really no, the framework, as I said in the comments, and as I said, it's like the framework is the same. It's there's just different approaches, right? And your experimental methods basically differ. Yeah,
And that's all we do at the grade school level is teach them the basic framework and how to think through it.
Absolutely. All you just need to do is do things systematically, minimize doubt, minimize bias, and you're good to go.
Absolutely.
The one thing the boss never ever said to me was, "What's your independent variable?"
It is whatever the hell is on the x-axis of the graph. It's simple as that. That's it. There's nothing to worry about. If it's on the x-axis, it's your independent variable, unless you have one of those skewiffy graphs that, for kind of clarity purposes, you may flip the axis. The ones on the side. Yeah, but you're gonna make it very clear.
Yes, if you can't read the abstract and figure out all of those things, you've done something wrong.
Absolutely.
Okay, man.
That
well, I'm kind of out of questions, actually.
Yeah.
Well, Terry Davies did clarify. He said, "Sorry, everyone's welcome."
That's okay. That's okay, Terry. I really don't feel left out, man. Well, AB, Blue, do you got anything else to add? Have we beaten this horse bloody, or do we still have some swings to take at this pinata?
Well, unless there's any specific, specific claims that people want to go into, then I think we're good. I think that horse is pretty bruised.
Yeah. Well, how about everybody in the live chat? If you've got any specific questions for AB and Blue, or Jeff and myself, pipe up now. Help us drive the conversation forward. We've only been at this an hour and 20 minutes, I think.
20, right. I do have something that's been provided by Mr. Bertelsen. What is the difference between independent and dependent variables that we can have a wee look at? It's just a website.
Okay.
If you're up for some of that.
Yeah.
Sure.
Go ahead. Pop that up on the screen. We'll talk about that.
So let's see where we can find it now. And we'll get it out in 2 seconds. Make sure I get the right one.
Now, is that 2 seconds in Scottish time or 2 seconds in European time?
Definitely be Scottish. Definitely be Scottish.
Yeah, I always tease Dick Dawson about that, because when we're on a private chat, he'll say, "Hey, give me 5 minutes and I'll be back." And a half an hour later, I haven't heard from him. So I tease him about Canadian time versus American time.
There we go. Right, just going to cut this wee thing down 2 seconds and we'll be right there.
Oh, good. We have musical entertainment. Thank you, Teddy.
Yeah, people in live chat, Teddy's not losing his mind. Yeah, it's just how he thinks by talking to his computer. It's perfectly normal. No medications are needed at this point.
My mind was lost long ago.
Unreal.
In fact, I'll have to do it that way. Then, no, you get back there. Apologies for this, folks, for my wee inner monologue.
Does this happen to be one of Anthony Riley's choice sources?
I think so, yeah.
Probably.
Mike was talking to me yesterday about Riley's cherry picking on these .edu sources and taking things out of context and not reading things before and after for the context, which I always find fun.
I like his standard of evidence. Oh, it's going to be from a .edu website. They are not reviewed, right? You can post as if you've got access to, if you're at a university and you just write a blog post and stuff like that and host it on the university's website, it's got an edu address. Doesn't mean it's right.
That's correct. And then I'm still waiting for him to answer my question about show me a .edu citation for density as a force.
Yeah.
Cool.
I think I'll be waiting a while.
No,
I think
you will. However, in the meantime, to save your weight,
Uh-huh.
Hey.
Hey.
Oh, there's graphs and numbers and all kinds of things that just
Oh, yeah.
probably gave AB a complete Woody.
Yeah, why don't you tell us what we're looking at here?
Well, you're looking at a graph, and
What dirt?
and guess what? On the x-axis, you have the independent variable, which is time. On the y-axis, you have the dependent variable, speed. And there are units which are important. And then, yeah, you've just got a quadratic relationship showing that it is accelerating, and yeah, it's doing a thing. Yeah, and we've got this this lovely article explaining the difference between an independent and a dependent variable, which I can't imagine that Riley would use this as a source, would he?
He would
I
never understand it.
doubt it. I doubt
Because
it because
time is the
altogether.
independent variable here. Let's see, he's talking about independent and dependent variables may be viewed in terms of cause and effect. If the independent variable is changed, then an effect is seen in the dependent variable. Remember, the values of both variables may change in an experiment and are recorded. The difference is that the value of the independent variable is controlled by the experimenter, while the value of the dependent variable only changes in response to the independent variable. Yeah, in a very, very simple, elegant experiment, but reality, it never quite works that way. The dry mix acronym? What? Okay. The dependent variable is the responding variable. Y is the axis on which the dependent or responding is graphed. Yeah, so basically, yeah, your independent variable is whatever you stick on the x-axis.
Some sources at the bottom as well.
Oh yeah, and some sources. That's always a good one.
What tickled me about this was on the left-hand side there, if you see under the headers, it's science, chemistry, and then the one that's actually got the wee marker against it.
Mhm.
Basics.
Basics, yeah, absolutely.
It's like, come on. I mean, how to tell the variables apart?
And several months ago, AB and I were kind of chatting it up, and he was telling me about he was in his lab one day, and he got the idea to try to gold coat a spider. Were you really concerned about the IV and DV when you were doing that, AB?
No, I was concerned about the spider burning up in my evaporator.
Which I think it eventually did, didn't it?
I didn't do it because it's an evaporator in an extreme kind of high precision system, and I can't exactly say where the evaporator sits, but yeah, let's just say that could be a cause for contaminations, which may be quite disastrous.
Yeah, but in the basic scheme of things, that still would have been a type of experiment.
Not really.
Can I do this thing?
Not really. I mean, that would just be coat it in some gold so I can stick it in an electron microscope. That's all. There was not really an experiment. I just wanted to take a picture.
Oh, okay.
It's never good when you get spider bits into your flux capacitor, though.
I know. I mean, last time that happened, I ended up back in the Victorian times, and God, that was smelly.
We got anything new in the side chat, Amy?
Actually, we do. We have some good ones. John Rapp says, am I correct in assuming that there does not necessarily need to be an independent variable in an experiment? And then Professor Phil Bell says the most important thing is to document your methodology. Peer review will pick up any of your faults. Mike Bertelson said the question will be, was Riley incompetent at research or was he being dishonest? Basically, his citations contradict all, and I mean all of his claims about the scientific method. But Riley doesn't include the graph or the explanation of how to graph the data, which is why Riley claims is not part of the scientific method. And Professor Phil Bell says Riley really does not have the intelligence to be dishonest. And then the casual space man says, what comment do you have about Riley saying that time cannot be an independent variable because you can't manipulate it?
I think that's a long-standing thing within the flat Earth community, isn't it?
Yeah,
You
it
can't
is.
manipulate it. It can't be an independent variable.
I can't remember which videos of his that I saw where he spouted that nonsense, but yeah, they're out there if you really want to do some digging, but it's going to take you a while to find it. But as far as whether or not he's incompetent or dishonest, I think it's a little bit of both. He's definitely incompetent in how he set up his little egg experiment, but he was dishonest about it in that he presupposed his own conclusions and made the data fit the conclusions, and that in itself is dishonest.
Well, looking at the positive side, at least he's competently being dishonest.
Or incompetently dishonest, yeah.
Yeah.
Competently dishonest. So he's incompetent, but at least he's competent in his dishonesty.
I am not too sure we can attribute any competence to him, but it depends on what kind of day you catch me. It's like sometimes I'll be there thinking it's like, no, he knows exactly what he's doing, and he's just being a twat. But on the other side, other days I'm like, no, he is too incompetent to be dishonest.
I think he's incompetent, but he knows what he's doing, man. Definitely.
Yeah, I did like how when you tried to build his model just to see if it would work, he jumped to the conclusion that you were trying to debunk him, and you weren't at all.
No.
And anybody who understands basic science could see that in your video.
But that's what I meant earlier with like you take an observation like his experiment and stuff like that, and then you then say, okay, that causes that. Okay, that's fine. That's fine. Let's take that as given. But you then have to test that further. You can't just say, there we go, science is done. I've shown that, I've proven it, science is done, let's walk away. No, because if you then have that cause and effect thing in quotes, then you have to try and describe that and build a model for it so you can test that, because then you can create more predictions saying, and then essentially what you're saying is like, well, if the mechanism for that result is this, then we should also see this other phenomenon, which in this case was heavy stuff should fall slower.
Mm-hmm.
And we kind of did something similar way back in last spring when you and I were playing around with that stupid donkey idea. We said, okay, what would it look like if the Earth was flat? And you started building models, and you found some very interesting things. One of the most interesting things I thought was that if the world was flat and we had a small local sun doing what they say it does, that there would be no ice at the North Pole.
It wouldn't be possible. There would never be it would never be dark at the North Pole. It would constantly be receiving heat from the sun, and it would melt.
Yeah, and you were still following the scientific method in that line of research, building a model based on what the claims are and finding out what the reality would be.
Yeah, because you take the claims, you build a model, and then you investigate what the predictions are, and you can test them. Now, in this case, you don't need to test them because, at the time, it was very simple. Is this correct? Let me have a look outside. No, it's not.
Yeah, and I like how they try to say, well, we don't live in a model, so science can't use models. Well, no, science does use models because science has to be able to predict to show itself valid or not,
Well, that's the thing. It's a model is just a formal framework in which you can make predictions, right? And they invoke that reification fallacy, and they'll constantly refer to the first paragraph on the Wikipedia page for the reification fallacy. But if they just scroll down, then they realize that they would read that the reification fallacy does not apply to science. And actually, logical fallacies full stop don't apply to science, because logical fallacies, as say the fallacious reasoning says, okay, if they have some statements which are true and one leads from another, and they can say, okay, that's a fallacious thing. But in logic, what you're doing is you are trying to prove things in the kind of mathematical sense. But you got to remember that in science, you are not proving things. And the common one is the affirming the consequent fallacy, right? If A is true, then we should observe B, and then we perform an experiment and we observe B, therefore A is true. If you think that science proves things, then that is a fallacy, and all scientific experiments are then fallacies. But you are not proving things. And that's the key point, and that's the whole reason why we always say it's like proof has no place in science, because if you're proving things, then you're committing fallacies.
Well, that's exactly what Riley's egg experiment was. It was an affirming the consequent fallacy from beginning to end. But keep one other thing in mind too. We can build models of lots of things and draw pictures of all sorts of things that cannot exist in reality. But it's pretty damn difficult to find something in reality that cannot be modeled.
Absolutely
True.
Absolutely, because if your model is consistent with reality, then the whole reification thing is no longer an issue.
Yeah, I can't even come up with an example, but that in and of itself should tell Flat Earth something. If we cannot model their flat Earth and make it work in a model, how in the hell could it exist in reality?
It can't.
Yeah, thank you.
One of my favorite videos here in the past, 6 or 7 days was Phuket Word trying to describe how solar eclipses work on a flat Earth while using a globe Earth model. I found that hysterical. And he didn't seem to realize that using time and date is, even though it looks flat because it's on your screen, it is a globe Earth model.
Exactly.
Well, yeah, and that's the thing. It's because they think, they go, well, time and date, we know, that is absolutely correct, because they somehow think that is based on observation, right? But in time and date, if I remember correctly, you can add your latitude and longitude to the 5th decimal place. Now, and it will give you an exact answer. Do you think that, let's see, so we've got 180 degrees in one direction, 180 degrees in one direction, so that's 180, so 1.8 million data points along X, then 300, yes. Yeah, you have a lot of data points that need to be recorded. Do you think that someone went out and went on every square foot of land, performed the measurements? Did you ever see a surveyor come through your kitchen and, stand in the back and performing the measurements for the exact location of your house? No, there's an equation. And the values you stick into that equation give you an output. And that equation is based on, guess what?
Somebody say it.
And it's a really simple equation as well.
Don't leave me in suspense. Oh my God.
I know. I am going to, because I'm evil.
I'm after my own heart. Davey, what's the next show you're on, mate?
Oh,
Because-
I don't know.
Because I'm going to have to handpick a video special for you, mate. For a man after my own heart. Yes, I like it.
Well, while AB is busy being evil over here, Amy has let me know that there's some comments going on in the live section that she would like to bring to our attention.
Yes,
Awesome.
please. Yeah. The Ugly German Truth asks, isn't it also important to test for or against possible alternative reasons and or influences? And John Rapp says, but does the thesis fallacy apply to science? And Ugly German Truth says, logical fallacies are 99% only relevant in philosophical reasoning. And we've got also what they have yet to model is a map. That should be a huge clue, but isn't for flat Earth. and Purple Rhymes with Orange says, Fleur still can't explain how he can predict an eclipse years in advance.
Yeah,
absolutely.
It's magic.
Yeah.
Actually, you can do it in your garage if you work at it.
Yeah, as far as the question about building models, absolutely. It's great to be able to model things that either work or don't work. And when they don't work and we get no results, the no results still teach us stuff.
Yeah, sure.
Well, but that's the thing. I mean, you also have to assume that your model is correct. Now, if you build a nice mathematical model, then, and the math is sound, then throughout the process, if you have the correct maths, then if your conclusion is correct or incorrect, is then basically dependent on whether your starting point is correct. And that's the power of it, because maths is, rigorous, and correctly done maths isn't wrong, because it is such a rigorous and well-structured logical framework, where fallacies can be a thing, by the way. But so, for example, what I did with the egg experiment, right, is you have your starting point was my formulation of how density would have to create a force. Now, that's fine. That's the starting point. And then there was lots of maths, and then there was a conclusion. Now, the maths was correct. So it's the starting point that must be wrong. And therefore, that invalidates his density as a force hypothesis.
Yeah.
Yeah, when you were talking about the purely mathematical models, you put me in mind of Stephen Hawking in his mathematical model for the Big Bang Theory. He didn't necessarily prove that the Big Bang Theory happened. He provided evidence for it with the math, because the math was working out correctly. But again, when we use theory, we have to explain that no, it's not common usage theory. It's scientific theory, means that there's enough evidence to suggest that this thing is true until more evidence comes to light that either would be for or against.
Precisely. In scientific theory, it is just the best available description. That's all it is.
Yeah, and it's just that simple. And we've been yakking about it for an hour and 45 minutes to just describe something just that simple, and it's actually a shame that we have to have shows like this to talk this long about something that isn't really that complicated, because there's morons out there that are just saying no, and we're not trying to, pull their heads out of their butts. We're trying to keep them from affecting the next generation and dumbing them down more than anything else.
Yeah.
Absolutely.
Well, anyway, Amy, do we got anything going on in the live chat that might drive this forward, or do we need to start thinking about wrapping up and grabbing some breakfast before we hop on over to Terry?
Actually, John Rapp had a question, and he said, am I correct in assuming that there does not necessarily need to be an independent variable in an experiment? Was that something that we already addressed?
Does there not need to be an independent variable in an experiment? Well, there has to be. There has to be, because you are looking for change with respect to something. Now, what the shape of that independent variable is, that's different. Now, if you are doing an experiment, like an experiment, the classical lab-based controlled experiment or a field experiment, then you manipulate the independent variable. If using observational methods, then your independent variable, and this is a line I try to refine a bit, but the independent variable is just a quantity that provides context for change, and you need that for everything.
Yes. I think it's perfectly plausible at times, not often, but at times you can begin with a set of possibilities, and you're not really sure which one ends up being the independent variable. It may not be immediately obvious at the outset of an experiment, but at some point you have to say, wait a minute, that's got to be the thing causing this. So we're going to control everything else, and we're going to vary that one thing.
Yeah, but then there's also additional complexity. Like, your independent variable may not necessarily be that obvious. If we just take Eratosthenes' experiment, for example, but we use more than, I have to say this every time, we use more than 2 sticks.
Yeah.
Right. And then we've got some measurements where we vary the latitude, and then we measure the angle of the sun. Right.
Mm-hmm.
Or the length of the shadows. Then if you're using that to test what the shape of the Earth is and how far the sun is and everything, then what is your independent variable? It's easy to say latitude is your independent variable, and then the shadow length is the dependent variable, but you would be wrong. Because you are testing different models, and then actually what your independent variable becomes, your independent variable becomes a categorical variable, which are all the different models that you want to test, all the different geometries of the Earth, and your dependent variable then becomes how well the data fits the predictions of that model.
Exactly.
So your independent variable is not always quite that obvious. It's not something that it may not even necessarily happen at the experiment stage. It could happen at the analysis stage, and that's your model could be your IV.
Yeah.
Well, I'm certainly glad you waited on that, AB, before I made myself look like an idiot.
Well, Bob, the science guy, and I did exactly that, AB. I mean, we did Eratosthenes. We did it at 2 latitudes that were 10 degrees apart,
Yeah.
without knowing what the outcome would be. We knew we could measure the sun angle. We knew we could do that. We knew we could assume radius or come up with a circumference of the Earth from that. But then when you sit down with the data at the end of it all and start trying to analyze that and see if it makes any sense, it's pretty obvious, as one of my college professors would have said, intuitively obvious to the casual observer that the sun couldn't be at two damn different altitudes at the same time. Something was wrong. And from that, we could then look at the combination of sun angle plus latitude, and figure out that in both cases it adds up to just about 90 degrees, real close, which is similar to the results you would expect if you're on a spherical surface. So yeah, it's everything you just went through. That couldn't have been the independent variable to begin with. But at the end of the day, it ends up being.
Yep, and I think it's important to note also that, like AB was talking about with the Eratosthenes experiment, that 99.99% of what the globe deniers do is try to provide evidence to disprove the globe model, But like he said in the Eratosthenes experiment, that doesn't necessarily mean flat. If you can actually provide evidence that the globe model is incorrect, now you're going to have to explore all the other different geometries to find out more, because just because it ain't one doesn't necessarily follow that it's the other. That's a false dichotomy. There's many of the other shapes in geometry, right?
Yeah,
absolutely.
And you have to test for all of them.
Yeah. And you have to say, too, when you're finished with all of that, as Bob and I completed that, we did not prove the Earth is a sphere at all. What we proved is between the two latitudes, between our two locations, it has a curvature that would be consistent with a radius of about 4,000 statute miles. Now, what happens on either side of that, we still don't know, right? We didn't test that.
Well, absolutely. But yeah, you just need to add, if you add a third stick, you can absolutely, where you can rule out more, and the more sticks you add, the more information you have, and the more you can test, exactly. Right? Because, for example, you could be on... You could be on a dodecahedron or something,
it could be
on a weird shape.
Yeah, right.
Yeah, that locally, you've got a region this is flat, and then there's a sharp edge, and there's another flat region. That could very well be, but you add more data points, and then you kind of eliminate all of those possibilities. Now, formally to say that the Eratosthenes experiment, if you perform it with lots of data points, to say that it proves that the Earth is a sphere would actually, or spherical, would actually be wrong. It's just that we've disproven every other geometry that we can think of. As simple as that. Yeah, we haven't technically proven that it's a sphere. There could be another geometry out there that we haven't discovered.
That's exactly right. What we have proven conclusively is that it, at least in those latitudes, is not flat.
Mm-hmm.
Precisely.
At least you've confirmed the predictions of the previous data.
Yeah.
Yeah, an ugly German truth said, you could be on a cylinder if you only demonstrate curvature in one direction. that's very true.
Exactly true. Exactly true.
Let me ask Blue and AB this. Since we're talking strictly about the scientific method and providing evidence and not providing proofs, would you consider the 1972 blue marble photograph of the planet as proof or evidence?
Strictly speaking, evidence.
I would agree with that. Strictly speaking, that is evidence. It's about as strong an evidence as you're ever going to find. But
yeah.
And I guess it would be, strictly speaking, evidence, because we're only seeing part of it. We're not, because of our limited size and scale and perspective, we cannot see all sides at the same time, right?
Well, we could be experiencing a mass psychotic break, and everyone on the planet perceives the picture in a certain way that is not real and stuff like that. But I mean, It's a possibility, but that's
Anything's
the standard of
possible.
evidence, right? It is a possibility, but it's the standard of evidence, right? It's like it's about confidence intervals. For example, like CERN, the detection of the Higgs boson, it's 7 sigma at now. It's saying there is a chance that it's wrong, but there is a there is a chance that we are wrong, absolutely.
Well,
But it is it's so small.
Infinitesimally small. It's there. It's real. It's always a chance. But
Yeah.
that was actually funny. You
probably stand a
said.
better.
I'm sorry, Blue. Go ahead.
I was just going to say you probably stand a better chance of hitting the lottery than having that be wrong. But
Yeah, when you made that statement of the mass psychotic break in the world's population, you put me in mind of something that my clients in the counseling office used to complain about all the time. I just want to be normal, Then I'd quip off with, normal is just a city in Illinois, But to think about that slightly deeper, normalcy is really just the viewpoint of the majority. So if 7 billion people were psychotic, they'd actually be normal to each other.
Well, yeah, I mean that's that's very true. But that's a different discussion. I mean, what is normal, and that goes into the whole topic of what defines clinical mental disorders and stuff like that. It's like, oh, is it a disorder? Is it because you got the whole field of abnormal psychology? It's like, what is abnormal psychology? And then, oh, hold on. Is it really abnormal? Because, for example, like we can say someone is really violent and really defensive and really quite aggressive, and then we judge that in society's context. We sit there as like, I grew up in a good family, I'm calm, and all of that. And someone who's really aggressive, I would say, that's abnormal. But what if they come in an environment where that's just a survival strategy and it's absolutely necessary to get shit done?
Oh yeah, we can nerd out on this all day and night too, because there's context is everything there. Because are we talking about a soldier on a battlefield, or are we talking about a drunken redneck beating on his wife?
Precisely.
But anyway, we've been at this just about 2 hours now, so let's check in with Amy one more time with the live chat, and if there's not anything that's going to drive us forward, we can start wrapping up. Because I don't know about you guys, but I'm getting a little hungry.
I just have a quick question from Mike Bertelson, and I think it would be pretty quick. He says, correct me if I'm wrong, but don't some behavioral studies not have a defined independent variable?
Well, they're not easily defined, as AB said. They're still there, but they might not be as clearly defined in until you get into the analysis stage.
Yeah, so they're not clearly defined. I mean, p hacking is a big problem here. But if you have a behavioral study, for example. I don't know. If someone think up of a result, just
well, how about
people make better exam partners? I don't know.
Sorry.
You were talking about thinking up a result. Well, the hypothesis could be, blue-eyed people make better study partners and postgraduate degrees.
But they have your independent variable. Yeah, but they have your independent variable, eye color.
Right.
Because in every behavioral study, you say people like this are more likely to do that, and then that property becomes your independent variable.
Okay.
Right.
So, like, if I'm doing like a Vineland assessment for my son, we have to do those, on a fairly regular basis. The independent variable wouldn't be quite as defined, but it would be there, correct? Is
Yeah.
that what it?
Yeah.
Okay.
Yeah,
Yes.
and that's what makes the statistical sciences like psychology so damn hard.
Yes. It's all Greek to
Yeah.
me too when I'm doing these things.
Yeah, which is why I opted for the clinical side, not the research side.
I know.
Yeah,
'cause they
clinical
send
can
me
still be
home, I
hard, but
think-
research, man, that's a bugger.
Oh.
Yeah.
Well, you should see the packets they send home for the assessments when it's time for that. It's like, oh my god.
Oh, God. So, anything else there in the live chat, Ames?
No, I think that's pretty much it.
All right. Well, let's go around the room, get some final thoughts, and start wrapping up. Jeff, why don't we start with you?
Yeah, I really enjoyed the show tonight, actually. I am by no means a scientist by any stretch of the imagination. I only teach science at the grade 3 level, but I actually learned a lot today. And actually, you helped refresh some things I learned in college that I had completely forgotten. So, yeah, thanks for a great show, guys. This was really, really awesome.
Yeah. And Big Blue?
Yeah, thanks for inviting me. I had a great time. It's always a pleasure to be on with AB and be on here with you guys. It was a stimulating discussion, I think.
We always love having you. Thanks for, answering the call whenever we ask. We always appreciate your giving us your time. And AB, what about you, buddy?
Yeah, well, thank you for having me on. It's been a good chat. Had a laugh. So yeah, thank you for inviting me. And I'm very happy to finally be on the show.
Yeah, we're looking forward to having you back again on the next one.
Oh yes, I'm back in a couple of weeks, aren't I?
That's right.
January
You're-
the 19th, noon GMT. You're going to be on with BM Furball. We're going to be sort of continuing this conversation. We're going to be discussing research techniques and how they differ between, like science and law enforcement and all that kind of stuff. Because the conspiracy theorists are always challenging us to do your research. Well, that's nice and a quaint little saying, but what does it really mean? And how is research really performed, right?
Excellent. I look forward to it.
Yeah,
it's
that
gonna
ought to
be a great
nice and
one.
fun. And that, again, will be on the iNetwork channel rather than this one. We will be putting up a little video, a little redirect video so that people know where to find us. Let's turn over to Teddy Boggle since he doesn't get a lot of airtime here while he's doing our production stuff in the background. What do you think about all this?
Oh man, I'm amazed that we can have such an eloquent conversation for 2 hours over quite on the face of it, simple subject, but it just shows that even the simple things, when you dig down into it, man, the detail and the minutiae that's involved, it's beautiful. It's beautiful. And as for listening to Big Blue and AB talk about this, man, oh Christ, can we do another 4 hours, man? I could listen to this all day.
Yeah,
You go
and me
ahead,
both.
Patty. I'm going for breakfast.
Yeah, I don't mind that Blue and AB actually make me feel stupid. I mean, I know I'm not. I'm just not educated in their fields, and it's okay to say I don't know X, Y, Z. The problem is when you find the answers or when somebody helps you find the answers to continue to say, nuh-uh, there's the problem. Sooner or later we have to at least say, I can provisionally accept this today. Amy, what do you think about today?
Oh, I thought it was amazing. It was just really interesting. Thank you so much, both of you, for coming on today. This was a really interesting conversation. And every time I come on here, I learn even more. I think this is great. So thank you very much. It was awesome.
All right, and with that, we're getting ready to say goodbye. Terry Davies, if you're still in the live chat, we'd be more than happy to pop on over there if you DM us a link for those of us that you want to join your live discussion. Give us a few moments to charge up our devices and grab a quick bite to eat, and we'll be with you shortly. And with that, I'll say good morning, because, well, it's still morning for me. Thank you for joining us, and we will see you again in 2 weeks. Teddy, let's go home.
Cheers.